Video is started. Good. So we're on lesson section 4.1. We are in the textbook, but we're not going to use textbook homework for a little bit because I want to kind of talk through some of these notes before we do. So we're in our notes packet for today and tomorrow. We're going to have to make one change to the notes packet. Just bear with me. The notes packet for you is that golden set of notes. We have some vocab we have to do. But before we dive into the vocab for 4.1, I want to make sure that we remember what our integer rules are. Okay? So, our integer rules, right? We've got our addition wrap, our add wrap. Click. There we go. So what's our wrap? Same sign. Add, different sign, subtract, and keep the sign of the bigger one so you can be exact. What? Right, and then for subtraction, if we have a subtraction problem, we want to keep change the sign. And then we add wrap, right? What's our multiplication rules?
Same sign, add.
Same sign, positive, different sign, negative. So we're going to really need to know these for what we're doing today. So we're looking at adding and subtracting. We're looking at solving equations using addition and subtraction. So when we solve equations, this is a little bit different. Let's get some vocab. Don't forget about our vocab from yesterday, variable. Right, it's normally a letter. Some examples, X, Y, and Z. I just realized I forgot to eat breakfast, so I'm going to eat. Sorry, all you video people, I forgot to eat breakfast today. So yesterday we talked about expressions, right? Expressions. What was an expression from yesterday?
Something without an equal sign.
Close, very close. Something without an equal sign. Awesome. Let's make it a little bit more direct than that.
Something without like a
No.
Oh.
Is 3 an expression?
No.
With the number 3? Not really. No.
And like a mathematical sentence with an equal without an equal sign?
Nope, because an equal sign makes it a sentence. What's a sentence that doesn't have a period, that doesn't have a full thought in English? Sentences are made up of a bunch of little...
Words.
Nope.
Parentheses.
Nope. Nope. Man, your English composition teachers will be upset.
Yeah,
Sentences are made up of small chunks. Those chunks are called sentences. We're talking about English, y'all. Expressions are math phrases. Everybody say phrases. Expressions are math phrases. Equations are math. Sentences. Equations are equations, they say. Chairs are chairs. Yeah, we're very enlightened. You know, an equation is a math sentence. So there's a beginning, a middle, and an end. The middle is the equal sign. The beginning is whatever the left side of the equation is. The end is whatever the right side of the equation is. So there's 3 parts to an equation, right? Beginning, middle, and end. Left side, equal sign, right side. Those are the 3 parts. Okay? When we're looking at solving equations, we really have to understand and know this idea. We want to solve an equation, we have to know what an inverse operation is. Everybody say inverse operation.
Inverse operation.
Good. What is an inverse operation, Saeed?
Adding operations that undo each other.
That undo each other. So if I add 7 to something, what operation, what would I need to do to undo that? If I add 7 to something, what would I need to do? Harsupin? I'd have to subtract 7. If I multiplied something by 8, what would I have to do to undo that? I'd have to divide it by 8. And that's the process. Understanding inverse operations is how we solve equations. Speaking of solving equations, what's a solution to an equation? It's a value that makes the equation true. Okay. So these vocab words are going to be very important for us. We're going to use these words quite often. I'm going to use inverse operation all day today. All day. Everybody say all day.
All day.
All right. And then today we're focusing on addition and subtraction, so we need to understand two properties. So follow along with me. Two properties. The addition property of equality states that if you add the same amount to each side of an equation, the two sides remain equal. So that's one of the things about equations that are really powerful. Now, equations aren't new. I'm pretty sure last year you guys talked about some sort of equations, right? You had some variables, and you had some equal signs. We didn't do a whole lot of solving. So one of the cool things about equations is this property of equality. Think about it. If I split the class in half, right, that means the two sides of my class would be equal, right? That means you guys would be, this side and this side would be equal, because you have the same number of people. What happens then if I walked over to this side? It's not equal anymore. What would I need to do to keep it equal?
Bring some of the people from this side to that side.
Exactly. I'd have to get Miss Kim to come over and stand on this side. She doesn't have to. You don't have to do that right now. She's there, so now we're equal again, right? I got a new student. Their seat's over here. Now what do I need to do to keep it equal? I need to add another student to this side. Equality is a really powerful thing. If I want to increase one side of an equal idea, I have to increase one side over here. That to keep it equal. Okay? The subtraction property of equality is the same thing. If you subtract the same amount from both sides, then that will remain equal, right? So let's say, I've got a student who's sick over here. In order to keep it equal, what do I need to make sure?
Make it student, Darius is sick over here.
Exactly, Darius is sick over here. So I've got one sick student over here, one sick student over here. I subtracted one from this side, so I subtracted one from that side. And now the two sides are equal still. What happens if I subtract one from this side and add one to this side? Uh-oh. To keep it equal, I should take that person from over here that I added, throw it over to the other side. Keep it equal. The idea, you'll notice that I'm doing this with my hands. It's because I like to think of it as a scale. Okay, I like to think of it as a scale. So the middle is the equal sign. That's the balancing point. Okay? If I increase, let's say, what happened here? What did I do to both sides of this scale? Well, I had an x over here on the right side and a 3 over here. 1, 2, 3. So x equals 3, right? What would x plus 2 equal? 5. Notice there, 5, because we added 2 to both sides to keep the scale equal. Okay? 2 weights are added to each side of the balance scale on the left. The result is the balance of the scale on the right. This shows a property of equality. This is the property of equality. What if I took these 2 away?
Then it wouldn't be equal.
What would I need to do to keep it equul?
You need to put those two back on.
No, actually, I wouldn't need to put those 2 back on. I throw them away. They're trash. They're rotten. I would need to take these 2 off of that side to make it look like this. So if I take 2 away from the left side of my balance scale, I also need to take 2 away from the right side of my balance scale. Okay? So here's what I'm talking about. Remember how I told you you'd have to make a change? Flip the notes over. This is the key idea for Unit 4, not Unit 2. Whoops. This is the key idea for Unit 4. Cross out that 2. Make it a 4. This is the key idea, all right? When solving equations, our goal, and we're going to say this in big, loud words, is to do what?
Isolate the variable.
Isolate the variable. I would say isolate the variable.
Isolate the variable.
What does it mean to isolate something?
You put that in a row with nobody else.
Put it by itself. To put it by itself.
Parentheses.
Okay? And how do we do this? We use inverse operations. Everybody say inverse operations. We want to use inverse operations. Right? It's our inverse. Hey, remember those inverse operations? What's the inverse operation for addition?
Subtraction.
They're on the front of your notes in case you're unsure. So what do we need to do? Our big goal. This is the biggest idea of what we need to do for Unit 4, all about solving equations. What do we need to do? Our goal is to do what? Everyone said together? How are we going to do it? So what you're telling me is we need to do what? We need to isolate the variable.
That's right.
Let it go.
For what?
Well, so wait, so you're really saying is that we need to put it maybe in a kingdom of isolation?
No.
Maybe? Maybe that's our goal. Maybe our real goal is to isolate the variable. You know, like Elsa in her ice castle. She's all by herself. Get it? We're gonna put that variable in a kingdom of isolation. Everybody sing it with me. Kingdom of isolation. Yeah, you rock. You're my favorite. I'm giving you candy.
I said it too.
Pop.
I said it though.
Oh, but we didn't sing it. We want to sing it. Yeah, so really what do we want to do? We want to isolate that variable like Elsa is in a kingdom of isolation, right? So we have this equation, number one for you guys. A couple things that we want to do to try to help us out. You guys remember that when we were combining like terms, we drew boxes and we drew shapes, we used colors. Those were things to help us start to see what to do. We're going to do a similar thing with equations. Now, I would imagine that some of you guys will not need to use these crutches for very long. But for today, I want you to see what we're doing. So there's a couple things that I do, okay? First things first, the very first thing I do when I see an equation is I pull a Donald Trump
Oh. Make a wall.
and I build the wall. Now, the only reason why I bring that up is because then it helps us remember, right? It's a memory device. So when we build our wall, what we want to do is we want to build that wall separating the two sides of the equation, not of the border, right?
Yeah.
So 1, 2, boom. It's a big old wall. There's a left side of that wall and a right side of that wall. You guys with me? And then one thing that I like to do to help me out is I like to circle the variable. What that helps me do, ready? I circle that variable. It helps me figure out what I need to get rid of. Because what am I supposed to do? I want to put the variable in a
Isolation.
kingdom of isolation. Okay. I want to isolate that variable. What does isolate mean? Elsa, when she's in her kingdom of isolation, she's all
By herself.
by herself. So what do I want to do with this x? I want to get rid of everything that's not in that circle. Right? So the last thing I do, step 3, let's do the inverse operation.
Addition.
Do the inverse operation where? To both sides. Why do I need to do it to both sides? Because because I need to keep it equal. If I do the inverse operation of this to one side, that scale is now imbalanced. I've done something to one side. To keep it balanced, I have to put it to both sides. So let's think about this. I've circled that variable to try to focus on what's not the variable. So on the left side, what's not the variable? Negative 19, right? It says negative 19. What's the inverse of that?
Positive.
Positive 19, so I need to add 19 to the left. Uh-oh, my scale is unbalanced. What do I need to do to rebalance that scale? What does it say? Inverse operation to both sides. So it's imbalanced right now because there's an extra 19 over here. I need to put an extra 19 over here. Now, one thing that I like to do is, you guys remember additive inverses. So we brought this up a while ago. Additive inverses are numbers that when added together will cancel out and equal 0. So these two numbers, negative 19 and positive 19, they're additive inverses. So what are they going to do? They'll cancel out and equal 0. So I like to cross it out. It helps me visually see what's by itself now on this side. X. X is by itself. Inside the wall is my equal sign. And what's on the right side? 45 plus 19 is 64. We have isolated the variable. We have found a solution to this equation. Remember, what's a solution from the front page? value that makes the equation true. So what I want us to do is, 64 is the solution to this equation. Let's plug it back in. Plug it back into the top. 64 minus 19. What does that equal? 64 minus 19. It equals 45. Hey, that's awesome. That means it's true. You can check your answers by plugging it back in. Okay? So this is what we're doing today. All right?
Does that mean the other worksheet we picked up was homework?
Yes. So stay with me. Let's see if I can. Here we go. All right, we got another one. So first things first, did you guys write down the steps that I wrote down in a space? The build the wall, circle the rope. Did you write that stuff down? I know that I didn't specifically put a space for it. I did that on purpose to try to teach you how to write appropriate notes, right?
Yes, sir.
To try to make it so that if I write something helpful, maybe you should write it too. If you didn't write it down, make sure you're listening so you can write it down as I talk through it. So the first thing I want to do is do what? Build that wall. Second thing I want to do, circle the variable. That helps me figure out what's not the variable. So what's not the variable? Use the words positive or negative. Positive 25. So the inverse of that would be negative 25. Uh-oh. My balance is unbalanced. My scale is unbalanced. I have more on the left than I do on the right. What do I need to do to balance this out? Exactly. I have to do the negative 25 on both sides. Now, for me, it makes sense for me to cross this out because those are additive inverses. Everybody say additive inverse. What does that mean? They cancel out to equal 0. And what's x plus 0? Just x, right? Anything plus 0 is that same thing. So I don't need to say plus 0, do I? And what's left on the left side? What's not crossed out? X. Inside the wall is my equal sign. And then on the right side, okay, they're both negative, right? So we need to add wrap. Same sign, add. Good. Different sign, subtract. Keep the sign of the bigger one. So there we go. It's going to be negative, and it's going to be negative what? Negative 33. So you see why it's really important that we know the add wrap. We know our subtraction rules too. Okay? All right, let's keep going. Doing one with decimals. All right. Step 1. Build that wall. Step 2. Circle that variable. The reason why I circle the variable is so I can focus on what's not the variable. So I can get rid of that, right? And how do we get that variable isolated? How do we isolate that variable? Look back at the top. How do we isolate that variable?
Use inverse operation.
Ashley? Yep. Use that inverse operation. Use that inverse operation. So the inverse of negative 8.8 is positive 8.8. Uh-oh, it's unbalanced.
And then you do the same thing on the other side.
Exactly. Now it's balanced because I've added 8.8 to both sides of my equal sign. Now on the left, that will cancel and I'm left with x. On the right, I think I might need to do some side work here. Why?
Because it's decimal.
That doesn't matter. What's 4.5 minus 1.5? Just because it's decimals doesn't mean that I have to do side work. I'm subtracting. I've got different signs, right? Same sign. Add. Different sign. Subtract and keep the sign of the bigger one so you can be exact. So let's decide on the sign right away. What's the sign of our answer going to be? Negative. I'm going to do some side work. So 12.3 minus 8.8. Okay. Cancel that out. 13 minus 8 is 5. Cancel that out. Give me a 10. Nope, actually that would be a 11, thank you. 11 minus 8 is 3. Bring that to the decimal. So 3.5. With the negative sign, right? And if you can do that on your head, that's cool, but I wanted to show you it's okay to do side work. But where should it be?
On the right side.
On the side. Notice, should side work ever be done here? No, why? Because there's this wall here. Can't do any other work here. That wall is keeping our sides, keeping our equation equal on both sides. Okay, let's skip this one for now. Actually, no, we are going to do this one. Let's do this one. What's different about this one?
It's variable on the other side.
The variable's on the other side.
You flip it. You just
We'll flip it. We can flip it now or we can flip it later. I'm going to flip it later. Okay? Build that wall. Circle the variable. How do I get that? How do I isolate that variable?
add 29.8 and use inverse operation.
Use inverse operations. That's what I want to use those math words. Use the inverse operations. So plus 29.8 on the right, plus 29.8 on the left. We'll cancel over here. And I'm left with, on the right side of my equation, an x. In the wall, an equals sign. And now this one we actually can probably do without having to do much thought. What's 8 minus 5? 3. What's 9 minus 9? And 2 minus 1? 1. So I get 10.3. Positive or negative? Positive, good. Now this isn't my answer. I want to put the variable first. So all I do is I flip it. I put x equals 10.3. It's going to be really important for us when we do that. To do that, when we get to inequalities, the variable comes first. So I want us to get in the habit now of putting the variable first. Are these equivalent? Yes. So I'm not going to kill you if you leave it like this. I just like you to get in the habit of putting the variable first. Okay? Let's do one with fractions. Fractions aren't hard. It's the same thing. We've done it before. We've done it over and over again. All right? Step 1. Build that wall. Then, circle the variable. How do I isolate that variable? I use inverse operations. What's the inverse of negative 2 over 5? 2 over 5. On the left, and positive 2 over 5 on the right. If you need to do some side work, that's fine. Do some side work. So we've got 3/10 plus 4/10, not 2/5, right? Plus 4/10. And that equals 7/10. So I've got x on the left equals 7/10 on the right. So if you need to do side work, that's fine. Where did the 4/10 come from? 2/5. 2/5 becomes 4/10 when I need to add. Okay. Questions on this one? All right. Sometimes my computer freaks out. Do what? Then? Then? Good. What's the inverse that I need to use? 5 over 6. Positive 5 over 6. Those will cancel, and I'm left with x on the left. Uh-oh, on the right. Same sign. Add.
Different subtraction of the bigger one, so you can use that.
What? Different sign, subtract. So this is going to be 5/6 minus 1/6, which gives me 4/6. But that's not done, right? That's not the answer, right? Why? You always have to simplify no matter what. Even if the instructions don't say simplify, that's an implied instruction. We always simplify. Okay, let's go on to some word ones. There we go. The sum of a number and 3 is negative. Wait, is. You guys remember from yesterday the word is? So let's just think about this one. The sum. What's that going to tell us we're going to be doing? Yeah. I'll put that in parentheses because the plus sign isn't going to come first, is it? It's going to go in between the two things. The sum of a number. So a number, that's something we don't know. 10. And 3. All right, so that would be a positive 3, right? Is. What's that? Equals negative 11. Notice, we literally just took the English and converted it to math. Now we have an equation. Okay? We build our wall around the word is. Let's write our equation. We want to do the sum of a number and 3. So how would I write that? Well, n plus 3, right? Because we're adding n plus a positive 3. And then on the right side of the equation, negative 11. And now this is no different than what we've been doing, right? Got my equation. I built the wall. Next I want to do, circle the variable. Now I want to use inverse operations. The inverse of positive 3 is negative 3, negative 3. Those cancel. I'm left with n on the left. Same sign add, different signs subtract. Keep the sign of the bigger one, so it'll be negative 14. Questions? So just converting those words. Be prepared to do some of those. There will be a couple of word problems on your homework, not too many, but just 1 or 2. Hang on. Awesome, thanks. Why is this one going to be a little trickier? Because it says less than. So are we going to read this one left to right?
No.
We're going to have to flip some things, aren't we? We're going to have to do some reverse. Okay? So less than, right away, we're going to write reverse it, right? So we're going to do this. 5, what's that? 5 is just 5. A number, it's n. And the words less than, that's going to be a subtraction, right? Is 20. Now, careful when we write this. We are not going to write 5 minus n. What are we going to write? N minus 5. N minus 5 equals 20. Guys, go ahead and solve that one. What are you going to do? Cool. All right.